Okay, exponential functions. All right, keep your phones away. So evaluate exponential functions, and then we're going to identify and graph exponential functions. So there's actually 4 different types of graphs we're going to end up looking at in this lesson. We're going to do the first 3 examples today, and then I think we might get to the 4th one, and then you'll actually have a couple problems from last night's some more practice. But the functions themselves, we're going to talk about them, is that we're going to look at the difference of increasing and decreasing of exponential functions. So it says the function rule that describes the pattern above is f of x equals 2 times 3 raised to the power of x. Now yesterday when we were using that subscript notation, we were actually writing function rules, we just weren't saying that they were. The difference is when I say something is a function, that means then that I'm using f of x. All right? Or f of t, or a of t, or something like that. We're not just saying y equals. Okay? So the function here would be f of x equals 2 times 3 raised to the power of x. And this type of function, we have the variable is our exponent. Okay? Notice when we were talking about things yesterday, that we are still going to be dealing with basically a sub 1 and r. Right? We're still going to be using this type of thing. Okay? Except we're negating the n minus 1, and we're just going to call that x. So we're going to get rid of n minus 1. We're going to call that x. Instead of using a sub 1, we're going to just use a. And instead of r, it's going to be b. So a times b raised to the power of x is our general rule for an exponential function. We really love exponential functions when a is 1. Okay, they're very easy to work with then. Okay? It's when we change it. And so we're going to be looking at when a is positive and negative, and when b is greater than 1, and when b is between 0 and 1. Those things all affect our answers differently. So here's example 1. It says the function f of x equals 500 times 1.035 to the power of x. Miles the amount of money in a certificate of deposit after x years. How much money will there be in 6 years? So here we just have actually just a calculator problem. Right? Can we put this in and do it correctly in our calculator? Right? Now, I have one question for you. What does the 1.035 mean? Who knows what it means? It's part of the problem, of course, but what does it mean? All right, Josh?
The interest rate.
So how much interest rate is there?
There's 3.5%.
3.5% interest rate, exactly, thank you. All right, this 1.035, the part after the decimal actually represents our interest rate. Okay, so in this case, this person is earning 3.5% on their money. Okay, and nowadays that's actually good. In the past, that was horrible. Okay, all right, so very easy, simple thing. We take our calculator, put in 500 times 1.035 raised to the 6th power for 6 years. Okay. So after 6 years, this person has earned $114 more, so $614.63 would be how much they have. Okay. Wow, that was hard, wasn't it? Okay, good. All right, so you got the easy ones out of the way. All right. Now, graphing them is where we're going to end up. It becomes a little bit tougher. In I expect, okay, all right, I guess we're not there yet, but I expect when you graph, though, your graphs are very, very accurate. Okay, you can't just draw a line and say, hey, there it is. Okay, we'll talk about that more. Okay, remember that linear functions have constant first differences and quadratic functions have constant second differences. You guys remember that? Learning about that? Okay. Exponential functions do not have constant differences, but they do have constant ratios. We were just talking about that. So we're going to be looking at, first of all, sets of data and determining whether they represent exponential functions or not. And so what we're going to be looking for is, do they have a constant ratio? And is it something that I can write in this form for an exponential function? So tell whether each set of ordered pairs satisfies an exponential function. Explain your answer. Okay. So the first thing we have to do when we have a set of data and we're trying to determine whether it represents any kind of a function is by looking at the values of x first of all. First thing is the values of x must change by a constant. Okay. So when I look at the x values here, 0, 1, 2, and 3, do they change by a constant value? Okay, they're all increasing by 1, right? All right, these all go up by 1. All right. From here to here, here to here, here to here. Okay. So we need to look at the y values then and see if they have a constant ratio. So to find that constant ratio, we have to divide. Okay, we take the next number and divide by the previous number. And when we do this, we have to do it with all of them, okay, to make sure they all agree. Okay. So we've got to do 12 divided by 4, and 36 divided by 12, and 108 divided by 36. These all have to agree. Okay. So do those all equal the same thing? Okay, which is 3. Okay, so we could actually, because the constant ratio here is 3, okay, we could actually use this information to write the function. So first of all, they say tell whether it is an exponential function. So the answer is yes. This is exponential. Now, since it's exponential, that means we could actually write the function, and I want to do that. So our general function for exponential is f of x equals a times b to the power of x. Now, looking at this table of values in our answer, can you tell me what a and b are? What are a and b? Now, yesterday what we say a was, we said a was our initial value, right? Okay. Now, when we're talking about functions, okay, the initial value is going to be when x equals 0, not 1. Okay. Because you notice when we started with 1, we had to subtract 1, right? We said a sub 1 equals r raised to the power of n minus 1. But when we're talking about a function, because we're just using x, not x minus 1, we're starting at 0. Okay? So what's the y value when x is 0? 4. Okay? So we're going to be starting with 4, and then each time we're going to multiply by 3, our value of b. So in this case, a is 4, b is 3. So if I want to write a function, we would say f of x equals 4 times 3 to the power of x. That would be our function for that one. Yep, it's going to be x. Awesome. Awesome. Don't waste my graph paper. All right, so let's look at letter B then. Here we have the numbers -1, -64, 0, 0, 164, and 2, 125. Okay. So we look at the x values. Do they change by a constant? Okay. All right. They all change by 1. Good. Okay, that helps us. All right, so we take the y values and we divide them. 0 over negative 64. Does that equal 64 over 0? Or 125 over 64? Are these all equal? No, they're not, because this one is what? 0. And what's this one?
Non-real number.
Undefined. It's undefined. I can't even say it's not a real number. I have to say it's undefined because you can't divide by 0. All right? Because what's 0 times 0? 0. So if I said that this equaled 0, okay, then that would mean that 0 times 0 would have to equal 64, but that obviously is not true. So, okay, so since these are not equal, then this is not exponential. And I'm going to give you a little, yes, Teresa.
How did you get those numbers? Like, how did you get 0 and negative 64 together?
You take the next one and divide by the previous one. Okay? All right? Now, I'm going to tell you something. I'm going to give you a hint here. Okay? All right, you ready for this? If this point is ever in your data, it's not exponential. Okay? All right. And the reason is because y can never equal 0. All right? Because if y equals 0, there's no dividing that can work in that case. So if you see 0, it's not exponential. Okay? So to graph exponential functions, we need to choose some positive, negative, and 0 values for x and generate some ordered pairs to graph them. All right? That would mean that somebody might say you can't use a calculator. Oh my gosh, don't do that, Mr. Coffee. Okay. All right, so we're going to start with graphing when a is positive, okay, a is greater than 0, and b is greater than 1. Okay. So if a is positive and b is greater than 1, okay, what does that tell me? What do you know if b is greater than 1, then the graph is going to go, as it goes to the right, it's going to go up. Okay, so this graph is going to go up as we go to the right. Now, and it's going to do that because a is greater than 0, so it's positive. Okay, so we're looking at positive a, starting value, and b greater than 1. Now, we want positive and negative values, so I'm going to start with my table, and I'm going to stick 0 right dead center. Okay? And then I'm going to go positive 1, positive 2, negative 1, negative 2. All right? And if you want to, you could even add a positive 3 down here. Okay? Probably wouldn't be a bad idea. Okay? All right? Now, I'm going to show you, I'm going to tell you how to do this in the simplest way possible. Okay? And you don't need your calculator to do it. Okay? All right. How many of you like to not be calculator dependent? Okay, only a few. All right, not surprised. Okay? Now, and this all boils down from using 0. Okay? Mr. Schultz, what is 5 raised to the power of 0? Alec, what's 253 raised to the power of 0? Erica, what's negative 73 raised to the power of 0? Depends on what the parentheses are. All right? So, but yes, okay, if I say that it's, if I actually said negative 73 to the power of 0, yes, that would be 1. Okay, if I said this, that's negative 1, okay, because the 0 does not affect the negative, all right? Just wanted to check you on that one. All right, so we're going to start here at 0. So I'm going to do 0.5 times 2 to the power of 0. And what's 2 to the power of 0? 1. So that means 0.5 times 1, which is 0.5. Okay? All right, so this is 0.5. Now, the rest of this is where it gets easier. Okay? All right? You can make it very difficult or you can make it easy. Right? And we're going to use Mr. Beebe's way of thinking. Okay? So, what's my value of B? 2, right? Which means that every time I go from one term to the next, I'm going to multiply by 2, aren't I? Okay? So to get from 0.5 for my 0 to 1, I'm going to do what to 0.5? Multiply it by 2. And what's 0.5 times 2? 1. Okay? Because all I had to do was 0.5 times 2 to the first power, okay, which is just 2 times 0.5. Okay? And then to get to the next one then, where x is 2, what do I do? Multiply by 2 again. What's 1 times 2? 2. All right, great. You guys are doing good. Okay, and let's go ahead and go to 3. What's 2 times 2? 4. All right, so I'm going to add this one here. All right, so we got a 4 there. Okay, so let's work backwards then. Okay, if I'm multiplying by 2 when I go to x is 1, x is 2, and x is 3, what if I go to negative values then? What do I need to do? Okay, all right. Instead of multiplying by 2, to go the other direction, I have to divide by 2. Okay, so if I take 0.5 and divide by 2, what do I get? Okay, 0.25. Right? 1/4 is half of 1/2. Okay, and then I divide by 2 again, and I get. Okay, half of 25 is 12.5 or 0.125. So when you're going down your table, or when the x values are increasing, you're using that value of b and multiplying by it. But then when you go up, you're going to just divide by that value of b. Okay? So then I plot my points. Let's see how I can do here. All right, so I got 0 and 0.5. And 1, 1, 2, 2, and 3, 4. And it won't do 1/4 here, I'm pretty sure. Nope, it won't. Okay, so I'll have to hand draw that one in. So I got -1 1/4, -2, and it's really close down there. Now, when you draw these graphs, are they going to cross the x-axis? No, because we can't have a y value of 0. Okay? Y value cannot be equal to 0. So the graph is going to look like this. And you must put arrows on each end and make sure your arrow going to the left does not do 2 things. Okay? 1, make sure it doesn't cross the x-axis. And 2, make sure it doesn't do this. Okay? Because the graph doesn't go back up, does it? No, it's just getting closer and closer to the x-axis. So make sure you don't put that in there. Okay? All right, so that's pretty easy to graph that, right? Okay, all right. But you got to use your head a little bit. All right, and you guys are all very intelligent, so I know you can do it. All right, so let's look at another one. Okay. Y equals 2 to the x. Oh, thank you very much. This was a good one. So we start out and make a table. All right, we're going to choose 5 or 6 values for x, whatever you want to do. All right, a couple negative, a couple positive. But we're always, when we make that table, we're going to start at 0. Easiest spot to work from. So the first number is going to be whatever the function is raised to the power of 0, where x is 0. And what's 2 to the power of 0? 1. Okay. Let's use, okay, 1. Okay. So our value of b is what in this case? Okay. Remember, it's a times b to the power of x. Okay? In this case, a is equal to 1 because there's no number there, which means it's 1. A is 1. And b is always the thing that's being raised to the power of x, which in this case is 2. So that's our common ratio is 2. So as we go down, as x's get bigger, we're multiplying by 2. As x's get smaller, we are dividing by 2. Okay? So what's 1 times 2? 2. 2 times 2 is? 4 times 2 is? 8. 1 divided by 2 is? 0.5 or 1/2. And half of a half is? Okay, 0.25. All right, all we're doing is that simple thing there. Okay. And we plot those points. Oops, that's all right. And draw our graph. Okay, so now we're looking at a is less than 0 and b is greater than 1. Now, how many of you had geometry already? Okay, most of you had, okay? All right, so you know about vertical reflections, correct? Okay, vertical reflections. What does it mean if I do a vertical reflection? Okay, everything goes from being positive to negative. That's all the y values, okay? Go from being positive to negative. So here's what's going to happen now, all right? Because a is now negative, it's less than 0. All of these graphs we did here, if I was to make this 0.5 negative, what would happen is that this graph would then look like this. Okay? Instead of it going up, because all those values were positive, now I'm going to make them all negative, so it's going to go down. Okay? So when we change a from positive to negative, instead of the going up, it's going to go down. Okay? So I'm not actually going to do that example today, all right? Because I'll answer some questions about it, but you have like 1 or 2 problems that are going to do it. So just make sure you understand this, that when a is negative, the graph is going to go down because instead of all these numbers here in y, instead of all those y values being positive, they're all going to be negative. Okay? And so the graph will look like that. It's just going to be flipped over. Okay? All right? It's flipped over.